Hey everyone, this is TheWover, co-creator of Donut and deinvoke as well as other open source projects. And today I'm going to give you a brief introduction to Donut as well as a rundown of some of its less known features and functionality. So to start us off, Donut, if you're not already familiar with it, is a framework that lets you generate shellcode to load common Windows payloads. This includes .NET assemblies, PE files, JScript, and others. And it also contains a number of defense evasion features, some of which we'll take a look at today. All right, so the first thing that we're going to take a look at is using Donut and debug mode to generate shellcode and test it. So a lot of people are not aware that Donut has a debug mode, but it does. So right now you can see these are the standard Donut command line arguments. And there's a lot of stuff here. We're not going to cover all of it, but we'll cover some of the more interesting ones, or the ones that people are not as commonly aware of. So now what I'm going to do is I'm going to compile Donut in debug mode. And I'm using the Visual Studio's native tools command prompt for this, as well as the MSVC makefile that comes with the source code, and specifying the debug parameter. And what this does is it means I can now run Donut in debug mode. And when I just run it without any options, I'll get the same thing I normally would. But then now if I use this and I specify a input file, in this case, I'm going to use Mimikatz. I'll specify the architecture as 64-bit. I'm going to get some shellcode, and I'm also going to get a lot of debug information that can be very useful in understanding why anything may have gone wrong if you're running the shellcode and it's not working. You'll get this loader.bin file, and this is your shellcode. You'll also get a instance file, and what this is a struct containing all of the information that the Donut loader uses to load your payload from memory. Now, the nice thing is when you build Donut in debug mode, it actually builds the loader itself as an exe that you can run from disk. So now if I do loader.exe, I can actually load that instance without having to have a shellcode injector to test it. And because I'm in debug mode, I get lots of information about how the file is being mapped to memory, different stuff like what are the addresses of all of the API calls that it was resolving, whether it had to use any forwarders or not. And then at the end of it, it will actually execute this shellcode and tell you what address it's executing at. Now, after all that, I've got Mimikatz running. I can get myself some coffee and exit. So next we'll take a look at generating shellcode on Linux. And a lot of people are not actually aware that you can do this, but yes, you can generate shellcode on Linux. And to be clear, this does not mean that you can execute the shellcode on Linux. It just means that you can generate the shellcode on Linux. So I've got a Ubuntu machine here, and I've downloaded the precompiled binaries from the releases page on the Donut repository. So I can run Donut, and when I just run it without any command line parameters, everything's the same, except for one thing, which is the compression options. There are some compression differences between Windows and Linux, mainly because on Windows, there's some options that use like a Windows API call. But otherwise, I can use it the same as I did before. I can specify mimikatz.exe, specify the architecture, and boom, there I go. I've got my shellcode, loader.bin there, and now I can take that shellcode, deploy it on the Windows system, and run Mimikatz from memory. The last thing that I'm going to do is give us a rundown of the common command line parameters that you would use with Donut. So the first thing I've done is I've changed from the short version of the name of each command line parameter to the long version, just so that it's easier for us to understand what we're doing. For this architecture option, this specifies what architecture of the loader Donut will build the shellcode with. By default, it uses the dual mode option, which includes a copy of both the 32-bit and 64-bit loader. Now, this is useful for .NET payloads or WScript payloads because you can have one version of the shellcode that you can inject into any process. However, for native executables, you're only going to be able to use one version of the loader anyway, and that's the one that matches your payload. So you might as well save on the size of your payload and just include the version of the loader that's relevant to you. In this case, since I've got a 64-bit version of Mimikatz, I'm going to specify a 64-bit version of the loader as well. Next, I'll provide the command line arguments for the payload itself. So in this case, I'm just using coffee and exit like I did before. Those are what are going to be passed into Mimikatz, and it'll behave the same way as it did last time. For bypass, I can control how the AMZ and ETW bypasses work. By default, if the AMZ or ETW bypass fails, execution will continue. But that can have safety risks where you may want to have execution abort so that you don't get a detection on running something after a failed bypass. So you can set that setting with number 2, or you can just turn them off. This next option is headers. So by default, Donut will overwrite the PE headers for native payloads. And this is a defense evasion strategy to counteract memory scanners that are looking for native PEs in memory based on their headers. However, this can cause problems with some payloads if they're actually using those headers, such as to access their PE resources. So you can just turn that off with this option. Then we're going to specify the output format. So by default, we just get loader.bin, which is the raw shellcode, and we can pass that into some shellcode injector. However, if you are creating your own custom loader in some other language, it could be useful to have it in another format. And there are converters out there, but Donut also can just, you can specify base64, C, Ruby, Python, and others. And it will just generate the output in that format as well, usually as something like a character array. And the last option that we're specifying is the compression engine, and that just specifies what algorithm is used to compress the payload. You can see on, whereas on Linux we only had 2 options, on Windows we have 4, and just as an example, I chose the LZNT1 algorithm. That's all we have for today. Just wanted to give you a brief introduction with Donut, and then I'm going to come back and go through some of the less known features and functionality, as well as some of the defense evasion options. Have a good day.